Dear students, in this session we start with vector followed by three-dimensional geometry. So you are familiar with vector, you would have studied in 11th standard. Dot product of two vectors. Vector product of two vectors. So we have studied in +1 these portions. Dot product or scalar product of two vectors. Scalar product of three vectors. Vector product of three vectors. Scalar product of four vectors. So vector product of four vectors. So we are going to discuss these concepts. So A vector dot B vector, A and B are two non-zero vectors. A vector dot B vector is defined as modulus A vector, modulus B vector cos theta, 0 less than equal to theta less than equal to pi. Geometrical meaning, that is projection of A vector on B vector equal to A vector dot B vector by modulus B vector, or A vector dot B vector by modulus B vector equal to B cap, that is unit vector. Projection of B vector on A vector, B vector dot A vector by modulus A vector, that is or B vector dot A cap. vector component of a vector on vector component of a vector on b vector equal to a vector dot b vector by modulus b vector squared into b vector. Vector component of a vector or projection of vector component or vector projection, component or vector projection. Vector projection of b vector on a vector dot b vector by modulus a vector square into a vector. So a vector dot properties a vector dot b vector equal to b vector dot a vector. Dot part is commutative. A vector and b vector are collinear. Then a vector dot b vector equal to ab or a vector dot b vector equal to minus ab. In this case a and b are the same direction, theta 0 degree. In this case a and b are the opposite direction, theta equal to 180 according to theta equal to 0 degree or theta equal to pi. A vector for non-zero vectors A vector and B vector. A vector perpendicular to B vector if only if A dot B equal to 0. If A vector dot B vector equal to 0, A vector perpendicular to B vector So A vector dot A vector equal to modulus A vector whole squared. I, J, K are three mutually perpendicular unit vectors. Then I vector dot I, J vector dot J equal to K vector dot K vector equal to 1. So I vector dot J equal to J vector dot K equal to K vector dot I equal to 0. So A vector dot B vector, you take A vector as A1I plus A2J plus A3K dot B1I plus B2J plus B3K equal to A1 B1 A2 B2 plus A2 B2 plus A3 B3. I dot A1 J dot J1 K dot Q1. So A1 B1 plus A2 B2 plus A3 B3. A vector dot B vector equal to modulus A vector modulus B vector cos theta. Cos theta equal to A vector dot B vector by modulus A vector into modulus B vector. Angle between two vectors can be found using this concept. A vector dot B vector by modulus A vector into modulus B vector. Some useful vector identities. A vector plus B vector dot A vector minus B vector equal to A vector squared minus B vector squared equal to modulus A vector squared minus modulus B vector squared equal to A squared minus B squared. A vector plus B vector whole squared equal to A vector square plus 2 into A vector dot B vector plus B vector squared equal to modulus A vector squared plus 2 into A vector dot B vector plus modulus B vector squared. So equal to A squared plus 2A dot B plus B squared. A square means small s a whole square, 2a dot b small s b whole square. A vector minus beta whole square equal to A vector squared minus 2 A vector dot B vector plus B vector squared. That is modulus A vector squared, or simply A vector squared means A squared minus 2 A vector dot B vector plus B squared. That is modulus A vector squared minus 2 into A vector dot B vector plus modulus B vector squared. Modulus of A vector plus B vector the whole square plus modulus of A vector minus B vector the whole square equal to twice modulus A vector square plus modulus B vector squared. And modulus of A vector plus A vector plus B vector whole square minus A vector minus B vector whole square equal to 4 into A vector dot B vector. So A vector dot B vector equal to 1 by 4 to modulus A vector plus B vector whole square minus modulus of A vector minus B vector the whole square, or 1 by 4 A vector plus B vector whole square minus A vector minus B vector the whole square. If A vector equal to A1I plus A2J plus A3K, so modulus equal to A vector dot A vector, that is A1 squared plus A2 squared plus A3 squared. Therefore, modulus A vector equal to root of A1 square plus A2 square plus A3 square. So modulus of A vector plus B vector equal to modulus of A vector minus B vector. If only if modulus A vector plus B vector the whole square equal to modulus A vector minus B vector the whole square. A vector plus B vector whole square equal to A vector minus B vector the whole square. If only if, this symbol is if and only if. So modulus A vector squared plus modulus or A vector square plus B vector square plus twice A vector dot B vector equal to A vector square plus B vector squared minus twice A vector dot B vector, which implies if 4 into A vector dot B vector equal 0. If only if A vector, this will be cancelled, bring this at 4 A dot B equal 0, that means A vector perpendicular B vector. So A vector equal to A1I plus A2J plus A3K. A vector dot I, that is A1I plus A2J plus A3K dot I, that is A1. A vector dot J, that is like that, if you operate you will get A2. A vector dot K, you will get A3. So A vector dot I int I plus A vector dot J into J plus A vector dot K into K vector equal to, for this A dot I is A1. So A1I plus A2J plus A3K equal to A vector. That is very important. A dot I into I plus A dot J into J plus A dot K into K equal to A vector. Resolved parts here R vector. Normally in this direction, the solved parts of a vector R vector, the direction of a unit vector A cap and the direction perpendicular to a cap or respectively or vector dot a cap into a cap and r vector minus r vector dot a cap into a cap. Along this direction, that one is perpendicular to a cap. The scalar and vector components of a vector or vector the direction of coordinate axis are respectively r vector dot I cap, r vector dot j cap and r vector dot k cap unit vector, and r vector dot I into I, r vector dot j into j and r dot k into k. Hence r vector equal to r dot I into I plus r vector dot j into j plus r vector dot k vector into k cap. work done by a force. Work done by a force effector causing a displacement d vector is effector dot d vector. Example, let's A vector, B vector and C vector be three vectors of magnitudes three, 4 and 5 respectively. 3, 4 and 5. Respectively. If each one is perpendicular to sum of other two vectors, then modulus of A vector plus B vector plus C vector equal to option A by 5, option B 3 root 2, option C 5 root 2, option D 12. So modulus A vector equal to 3, modulus B vector equal to 4, modulus C vector equal to 5. A vector perpendicular to B plus C, B vector perpendicular to C plus A, C vector perpendicular to A vector plus B vector. which means each vector is perpendicular to sum of other two vectors. That is a given statement. A vector dot b plus a equals 0. B vector dot c plus a equals 0. C vector dot a vector plus b vector equals 0, which implies a dot b plus a dot c equals 0, b dot c plus b dot a equals 0, c dot a plus c dot b equal to 0. Adding twice a dot b plus twice b dot c plus twice c dot a equal to 0. Which implies a dot b plus b dot c plus c dot a equal to 0. So modulus of a vector plus b vector plus c vector whole square equal to modulus a vector square plus modulus b vector square plus modulus a vector square plus twice a vector dot b vector plus b dot c plus c vector dot a vector. Just we have written a plus b plus whole square formula we have written. So 3 squared plus 4 squared plus 5 squared plus this is equal to 0. So 9 plus 16 plus 25, that is 50. Modulus of a vector plus b vector plus c vector equal to root 50. That is 25 into 2. 5 root 2. The set of values of A for which the vector or vector equal to a squared minus 4 into I plus 2j vector plus a squared minus 9 into k makes acute angles the coordinate axis is -3, -2 union 2, infinity, -3, -2 union 2, 3, minus infinity, plus infinity. Cos theta equal to A vector dot B vector by modulus A vector into modulus B vector. For theta to be acute, cos theta greater than 0. That means A vector dot B vector greater than 0. For vector or vector to be inclined, acute angles with coordinate axis we must have r vector dot I vector greater than 0, r vector dot j vector greater than 0, r vector dot k vector greater than 0. R vector dot I vector a square minus 4 into I plus 2j plus a square minus 9 into k dot I vector equal to a square minus 4. Your minus a square minus 9. So r vector dot j vector, that is, if operate with j vector, you will get 2, which is greater than 0. So r vector dot k vector, a squared minus 4 die plus 2j minus of a square minus k dot k vector, that is minus of a square minus 9. So r vector dot I vector greater than 0 implies a square minus 4 greater than 0, a plus 2 into a minus 2 greater than 0, which implies a is less than minus 2, a is greater than 2. Inequality what you have studied, a x minus alpha into, which implies x is less than alpha, x is greater than beta. Using this, a is less than minus 2 and a is greater than 2. R vector dot k vector greater than 0, which implies minus of a squared minus 9 greater than 0. A squared minus 9 less than 0. So a plus 3 into a minus 3 less than 0, which implies minus 3 less than a less than plus 3. X minus alpha into x minus beta less than 0 implies alpha less than x less than beta. A less than minus 2, a greater than 2, and minus 3 less than a less than 3, which implies greater than minus 3 less than minus 2, that is minus 3 to a belongs to minus 3 to minus 2 union greater than 2, which is less than 3, 2 to 3, minus 3 comma minus 2 union 2 comma 3. So option C is correct. Cross or vector product of two vectors. A vector cross B vector equal to modulus A vector modulus B vector sin theta n cap. That's the formula. n cap is perpendicular to A vector and B vector. A vector cross B is perpendicular to A vector cross B vector is perpendicular to both A vector and B vector. So important points. If A vector equal to B vector or A vector is parallel to B vector, then sin theta equal to 0. So A vector cross B vector equal to 0 vector. A vector cross B vector the direction of A vector cross B vector is regarded positive if the rotation from A vector to B vector is appears to be anti-clockwise or counterclockwise. It is in this direction we have to move. A cross B is perpendicular to the plane which contains A vector and B vector. the unit vector perpendicular to A vector and B vector are to the plan containing A vector and B vector is given by A vector cross B vector by modulus of A vector cross B vector. Vector product of collinear or parallel vectors is 0. A vector cross B vector equal to 0 vector, then A vector equal to 0 vector or B vector equal to 0 vector or A vector and B vector are collinear or collinear means like the same line or parallel. So A vector cross B vector equal to modulus A vector modulus B vector sin theta n cap. You take modulus of A vector plus B vector equal to modulus A vector modulus B vector sin theta, since modulus n cap equal to 1. From this sin theta equal to modulus of A vector cross B vector by modulus A vector into modulus B vector. Still we have few more concepts to be discussed in this cross product of two vectors. Let us discuss those things in the next session. Thank you.